Okay, today I want to cover something that I've had to do several times recently, which is install my code as a Python package on a Docker container. It's a couple of ways that setup tools and Docker kind of conflict with each other that's made it a little trickier. And these are just some of the tricks that I found to make it a little bit nicer. So there's a few prerequisites you should probably know. Some bash basics, mostly for making directories, a little bit in the Docker file. The Docker fundamentals, what layers are, why you should keep them small, that kind of stuff. And then just a skosh of knowledge about REST APIs and HTTP verbs. Basically, get is the only one that we're going to use for this. There's two goals that I really want, which is installing our Python package in editable mode when building a dev image and installing it as a wheel in a production image. That way we can still change our code and work with it while doing development, but have a fully primed and efficient wheel when deploying this into production, and we get all the efficiencies and benefits of that. But I also won't allow for hot code editing or live code reload. There's a bunch of ways to talk about that, but basically, without having to rebuild the image and spinning up a new container, I want to be able to change my code, have those effects inside of the container, and that just makes test-driven development a little bit easier. So we're going to go ahead and get started and start by creating the necessary folder structure. So I'm already in kind of the top level directory. If you're cloning from a Git repo, this would be the name of the repository. But I want to make a directory that's going to be for my app, and then a source code directory. I'm going to call it tutorial in this case, and I want that to go under app, and a directory under app for my tests, and that just keeps things nice and clean. If we look over here, you'll see that there's now an empty test and an empty tutorial folder. The first thing that we need when building a package is a setup file, and that's going to go inside of the app directory. And I don't know why I decided to do that through the UI instead of terminal. But I like using setup tools, not setup tools. And it's basically one function call we're going to need, which is just setup. And we're going to pass the name of our package. In this case, I'm going to call it tutorial, and that is the name that is going to show when you do a pip list. It's going to show you the name of the package. Because this is the first iteration, we're doing version 0.1.0. We're going to come back to install requires. This is about getting the requirements.txt file installed when building your package. And then I also need to point it at the packages to run. You also have available the find packages call, which is really helpful the larger your project gets, because this one is really small. We're just going to point it specifically to the package. In this case, tutorial, which is going to be this folder right here. That's the one where all the source code is going to be without any tests. So one of the things that I found especially frustrating is keeping my requirements.txt file in sync with the list of requirements here. So a coworker of mine actually pointed out there's a really clever way to keep them in sync, and that is to just read in the arguments right here. Actually, I don't even think we need to do that. And then we're just going to read directly from the file, split lines, and that's going to give us a nice list of requirements. And we just pass that into install requires just like that. Whatever goes into our requirements file is then going to get installed every time we try to build the package. That's just the first little efficiency I found. It leaves you with just one place that you have to build these requirements out. One of the other things that we need is, well, I guess at this point, the next thing we need is the requirements file. Otherwise, this is going to fail trying to read in a non-existent file. So if we go into that app, we're just going to go ahead and touch requirements.txt. Boom, there it is. And the only requirement we're going to have for this project is requests. We're just going to say version 2.7. So the next efficiency that I found is, because we want to keep Docker images as small as possible, we want to install test requirements only when building a dev image. So we're going to touch requirements test.txt. It'll pop up there. And this is just going to hold all of our test requirements, the things that only need to be installed when we're running tests. I'm a big fan of PyTest, so we're going to start with PyTest and then PyTest mock. And those are going to be our test dependencies, which we will get to how those get installed differently since they're not installed through the setup py file. But the next thing we need is some tests. And we'll go ahead and change into that file, or that folder, I'm sorry. And we're going to create test postman.py. And so what I'm going to do here is just use the Postman Echo REST API, which is a really easy way to just test kind of your HTTP interactions. It's something Postman provides for free. And what I want to do is basically just hit the get endpoint that they provide, just to make sure that we can get out there. Gives us a simple thing to test and a simple thing to code. So in here, we're going to import PyTest, since we're using PyTest instead of unit test. Well, we won't do that import because it doesn't exist yet. This is just a really simple mock response object that kind of replicates the things that I need from the request response object, which is, for our purposes today, just the status code property. Then I'm going to create a PyTest fixture. And this is another pattern that I like to use a lot, where we're just going to provide a function that mocks a very specific part of our project, but it returns a function of itself, and that actually allows it to change the return value. So you'll see here that the mock get function is going to return create. Inside create, this is where we're actually going to do the mock. We're going to use mocker, which is a built-in wrapper around unit test mock. And we are going to patch. And again, this is going to fail until we add the source code. But we're going to mock out from our tutorial package, the Postman module, its instance of request, and the get function of get. And the return value is going to be just a mock response where we pass in the status that we get up here on line 9. And so this way, when we call mock get with a status code, what we're really getting is a mock object of the request get action. And then we just need a simple test for a successful get. We're going to do some dependency injection there. PyTest automatically knows, because we have a fixture named mock get is going to get passed in right there. And my response mock is going to oh, I've got a typo, is going to be a mock response with a status code of 200. That's how you would actually use it. Then we want to assert that postman.get equals 200. I guess we will add the import for it. So from tutorial, that's going to be our package. We're going to import the postman module. We'll have a get function in there. And that's going to be our first test. We also should test what we're going to do on a failure. And once again, we want mock get passed in. And our response mock is going to be, let's call it a 404. Why not? And then we want to assert that postman get is going to equal a 404. And then we have some tests there that we can run. Now we actually need to add our source code. And this is where we're going to get into some of the more of the specifics from our setup.py file. So because it's looking at this tutorial package, we need a init.py file. And that's what indicates to it that this is a package. That's kind of how it does its auto discovery. We need our main entry point, which is just going to be main.py. From here, we want to import, not impost. We want to import postman. And our traditional main. So we want to do get status is postman.get. And we're just going to print out our code, our status code. We're going to print out our status there. The last thing we're going to need for this is, of course, the postman.py module. This is the thing that's going to do all of the magic of working the Postman Echo service. So what's going to get imported for test is what's getting imported to main, all that good stuff. This guy's pretty easy too. We're just going to import requests. And we're going to provide that get function that I said we would. And then we just call request.get. And it's postmanecho.com. If that's wrong, we're going to find out when we do our unit tests. And we're just going to return the status code. And that gives us something real simple that we can run there. When we do the setup, we're going to have a package named tutorial. It's actually going to look for our tutorial packages and install our requirements. Just a reminder, our only requirement is requests. And what that's going to do is call the get endpoint and then print out what our status code is. And that is what's actually doing the action here. So at this point, we could start installing it locally and all that kind of stuff. But the point is we want to build this inside of a Docker container, have it available with live code editing, and have kind of a different dev image versus a production image. So we're going to go back out to our root directory here. And we are going to start with a Docker file. There we go. And the first thing that we have to do in our Docker file is say which image we are coming from. So we're just going to go ahead and pull Python 3.8. So Python is the actual image name that we're working from. This is an official Docker image. And then the tag I'm grabbing is 3.8 because Python 3.8 just came out, so why not use it? This is where we start defining how we're going to differentiate between a production and a dev image. And I use that through Docker arg. And the reason I do that is arg is only available during the build context, not to containers after the image has been built. And I prefer it that way because building a dev image, it should only be used to spin up dev containers. A dev image should not allow for a container to spin up and think it is in production. That's how you drop databases and things like that. So I tend to use arg instead of env. There's some reasons why you wouldn't want to do that, but that's my primary reason for it. Then we want to set our working directory. This can really be anything. I've never found like a great best practice for where you should put it. So for me, user source app is just like a default location. And as long as it's staying consistent, I don't think it's any harm if you're doing a lot of different containers. We're going to copy in our app code. So what that's doing is taking our current directory and then copying in app. So as a reminder, app contains the test, the tutorial, the requirements, the setup.py, and it's putting it into our working directory on the container, which is user source app. And that's the reason that I had the app folder there. When we go to do live code editing, if I didn't have that, and I just copied in everything from my root directory, then you start overriding like where the module is, and you get some permissions issues, and it can be really wonky. And so this just gives me a nice isolated way of where it's like, that's the Python, and then everything else that is not part of the Python package can sit outside of that. This next part gets to be a little bit tricky, but it, for me, is really where the magic happens. So if that target environment is production, then we want to run pip install wheel. And what that does is installs our package as a wheel. But if we're not in a production image, what we want to do is pip install those test requirements. That's how we're going to get those into the container. And pip install -e, same thing. That is going to end the if block. So what we're doing here, again, just because it is kind of complex, if our target environment is production, install our package as a wheel. Else, install our test requirements, allows for production images to be smaller. We don't have all of those test requirements inside of the image. That's only on dev. And then we install it as a package. And then our final step is to do the entry point and the command. And the way that this is recommended to be done is you specify a basic entry point, and then you provide any arguments to it using command. So I can't type. So our entry point is going to be Python, and our command is going to be and that way we're going to run our Python tutorial. And so there's this little error here, and it's because I forgot to escape the new line. And so now that would be valid syntax. So at this point, we can go ahead and try to build our image. And the command that you can do that with is docker build. And we always want to tag our images. Otherwise, you get a bunch of these no name, no tag images, and it's really hard to know what it was supposed to be, and you end up just deleting them all just because you need the space. So we're going to call this guy tutorial latest, and we're going to build the Docker file in our current context. Assuming I haven't done anything incorrect. Perfect. So we should at this point have a production image ready to go. And if we go up here, you'll see that the only package we installed was requests, and that's how we want it right now. And so what we can do is just run that container now to see what it does. And if everything goes right, it should print out get response was returned with a status code 200. That's exactly what we wanted. But let's say we want to run the tests. We can do run dash dash entry point equals PyTest. And this is going to allow us to run the unit tests. And it failed exactly like it should because this is a production image without PyTest installed. So now we want to go ahead and rebuild this guy as a dev image. We're going to go back to our build command here, and we're going to provide the build arg flag, and we're going to say that target env is equal to dev. And when we rebuild this guy, you'll see a whole lot more packages just got installed here. And that's because we're installing PyTest and PyTest mock, and they have some dependencies of their own. And now if we go and try to run this PyTest entry point again, we can do that. And you'll see there we have 2 passing unit tests, which is testing a successful get and a successful failure. But the last thing that we really wanted to achieve was being able to do hot code editing. And the way we have to do that is by using a bound or a bind mount. So the command is docker run, and forgive me, I've been neglecting to put the dash dash rm. That forces the container to remove itself when it's done. It's just a good habit to get into to keep your Docker environment clean. And so we're going to specify mount type is bind. Its source is our working directory /app. And the destination inside the container is what this is looking for is the working directory setup, which is user source app. All right, we should run this guy. He should still be working, and he is. But now we can go back up to our code. So we can go into like the test here, and we're actually going to be able to write some more unit tests. So let's say test get server error. No, I haven't rebuilt the container yet. I've just been running, or I haven't rebuilt the image. I've just been running containers off of that same image. I'm going to say the response mock is equal to a 500, which is an internal server error. We're going to do postman get. And so now if I try to run this guy with our unit tests, you'll see 3 tests instead of 2. And that's how you do the live code editing portion of it. So that's what I found so far. I hope you found this helpful and insightful.